So second, this is the second problem, and this is the second problem is it's a compound, and it's about what is called the lattice energy, and it's actually the question is enthalpy diagram. I'm going to draw it. Calculate the electron affinity of bromine, and a bunch of other values are given, and I kind of wrote it down here. Okay, what in a sequence that is up here, standard heat of formation of NaBr, I put it. But do you notice that NaBr, they being ambiguous, you have to figure it out. Standard heat means standard state. NaBr is a salt, as a solid, so it's actually, you should write it down as a solid here. And then the energy to vaporization, so I think that one is very clear. And the sublimation, solid to gas, that's one of the ones. And first ionization energy, sodium, in here you have to understand that sodium is actually a gas. Because when you have the solid sodium, it has on the lattice, it has an extra energy state. So when you have no structures, sodium atoms are flying around as a gas. That's the right state. We just worry about taking one electrons out. That's the first ionization of sodium. So, when they write this, purposely they are being ambiguous, and you need to figure out that means must be sodium gas. The bond energy of bromine, and what state? Is it liquid or gas? The one without any structures is what is molecular level understanding. So once again, that is also gas. So this is something that being ambiguous there. And even lattice energy, they didn't write here, but lattice energy of this salt, is a sodium bromide solid. Okay, so that's a lattice energy. And what is an electron affinity? I mean, I wrote it up there, but electron affinity is actually, we are dealing with atom receiving an electron to get to the electron rich state, and this is in a gas state that doesn't have any structures, right? Solid has the structures, right? Liquid has sort of structure, but gas has no structures. So anything about this, ionization energy, bond energy, electron affinity, all gases, right? Standard heat of formation and the lattice energy of this compound is in the state of solid. Okay, so that's the first thing. Okay, so now let's do what is my next step is I need to write down the equation in a form. Let's do the practice here. Okay, I'm gonna write it down. Standard heat of formation. So what that means is, what is the state of sodium in the standard state? They are solid. Have you seen the sodium like a chunk in the left? They are solid. What about the bromine? This is all hard. You have to have a pre-existing knowledge. Is a bromine is a gas at room temperature and ambient pressure? Or liquid? Does anyone know? Bromine is a liquid, because bromine is a bigger one. The bigger it is, it's hard to vaporize. So bromine is actually liquid. So bromine 2 is a liquid in the standard state, and half of them react, and then they will make sodium bromide solid. That is what is called a delta H heat of formation. Okay, for this sodium bromide. That's the first step that you need to know, and this is actually most important step. A little extra that if you have a chlorine, okay, if you have a sodium chloride and a sodium bromide, the same problem, very similar. And in this case is actually standard state, this is actually gas. We know the chlorine is a gas, probably you saw in the movie or something, it's like the yellow gas is coming out, and those are the chlorine is a gas. Whereas the bromine is a liquid, so you have to deal with liquid became vaporized liquid lose a bond, and losing bond, and you're getting the electron. So you need to build up the stories and how the whole thing is makes sense to us. So let's break things into individual. Okay, so this is the first one, and I will jump on to the actually second one here, the last one, lattice energy. Lattice energy is also the same as, so delta H lattice, and you form this crystalline solid. From where? Anyone know? Do you know what lattice is? I think we talked about it in the, I know it's I saw that in the earlier. You have this crystal of sodium plus, bromine minus alternating. They call the rock salt structures of some kind of cubic lattice. They kind of pattern nicely, form this solid. So what's the like a contrasting state before they become sodium bromide? You want to make a guess? We are talking about sodium plus as a gas, bromine minus as a gas. So these are the two flying species because of the sodium is 8 sodium plus as they are stable. Bromine is bromine minus, they are stable. As a gaseous species, they have no structures, so no lattice. Everything is on a lattice. That's the only differences between these two. So that's the definition of lattice energy. So that's the two portion that I am done. And then the heat of vaporization is, I think that you all know, liquid, you just vaporizing it. Sublimation is solid becomes gas. So those are the one I can easily write. What about the first ionization of energy of sodium? So that means energy needed. So sodium gas becomes sodium plus gas with losing 1 electrons to the surrounding. Okay, so I'm doing that. And the last one here is a bond energy. Bond energy is energy to break the bond, right? Br2 gas making 2 Br gas. So I guess that's that. So far so good, right? So far so good. And then I here categorize in the red and the blue, and you should realize liquid to gas, solid to gas, it takes energy. So energy level goes up, right? Ionization energy, the sodium, you need to put the energies there to kick the electrons out. So you need to put an energy there. So it's an energy elevation process. Bond energy too, you need to put the injected energy to break those bonds into 2 atoms gas. Whereas those two are the one that will be forming a stable compound, so their energy is actually coming down. So that's forming a lattice from latticeless gas, so that's energy is coming down. What's the last one? Which is we talked about, it's shown up there. It is about bromine gas taking the electrons and become happier bromine minus gas. Okay? As you recall that this one do not satisfy the octet rule. When they have an electron, they'll become octet rule satisfaction. So at least the energy state is getting lower. So I had kind of the chewing down those numbers, and these numbers shown up there. That's why the standard heat of formation is negative number because energy is coming down. This is lowering the state. And the heat of vaporization, positive number, energy goes up. Sublimation, energy goes up. And then this one is ionization energy, energy goes up. Bond energy, energy goes up. Right? Lattice energy, energy comes down from this, I guess, ion gases into us, putting it on a lattice space. So I put that in, and how do I make this one? Everything is connected, and this is what I'm going back to this, what is called energy enthalpy diagram. This is a von Haber cycle. This is Dr. Ma talked about this, or have you seen that? Have you guys seen this in the class? Yes? No? I'm going to go through it, so don't worry. I'm going to go. Okay. So where do I start? Is actually this to me the most important one is this. So I want to know at room temperature, by looking at the problem, I know there's sodium and bromine is involved. And the sodium as it is pure state is a solid. Liquid bromine is their standard state form. So from here, I can do whatever I want. I can go make this sodium to vaporize, I don't know, ionize, and so on. And going through all kinds of circle and going back to the original. And this is all process. Just like I told you before, from the Albany, you can go to the New York City, Allentown, North Pole, South Pole, Jupiter, wherever you go back to Albany, your delta H is 0. So whatever the process, you can keep track, and we saw this one before. So this is my starting point, and you just have to build up the stories, and knowing that energy goes up, comes down, and then whatever the cycle that you see start to make sense. So I need to go now to build up the story from here. Okay, so the delta H over the cycle process is either this way, is 0. That's the one that I'm going to use. Okay, so given that, so let's do this. All right. So I'm going to start with sodium solid, half of bromine gas. So this is my state. And then what I'm going to do is I am going to say, okay, I think that the first thing that I know is, yeah, okay, sodium bromide solid, this energy. This is what we call delta H formation. That's a heater formation. Does it make sense? Right? So that's the one. Part of the, I'm going to make a big cycle, but this is one of the segments, and then maybe I can use a different color just to visually interesting. So then the other route that I can do, and I can do whichever I want. First I can do, I want to make this one vaporize. So that's the sodium solid, half of bromine now gas to be generated from the liquid. That is a delta H vaporization, but you have to multiply by half because it is only a half moles of bromine. So I just vaporize liquid bromine to the gas bromine. And then I guess I have to also vaporize too, the sodium. So that's the sodium gas, keeping the other partner the same. And that's a delta H sublimation. And this one is sublimation is, I guess that's the thing. Okay, just 1 mole, so that's just fine. So from here, I can just directly make sodium bromide from this state, but I'm going to make this detour, right? So I came from the Albany to New York City, but now Albany to going to all the other places to get to here, and that's what I'm doing now. Okay, and what else did I do? Yeah, so you remember ionization of sodium plus, right? So right there. So I'm going to ionize. So this is ionization energy of sodium. So you are generating sodium plus electrons and then half of bromine gas. So I guess I just do that. And then what else need to do is, okay, sodium is done, but now this is you need to break the bonds, right? So you need to break the bonds, and so keeping the sodium gas electron as it is, and then you are going to break it the bond and bromine atom as a gas, and this is a bond energy. So what it would be? These all process shown in the red, right? All shown up in those processes. Finally, to generate this state, that is a state that is up there, and all you got to do now is, this one was, they love to lose an electron, but this bromine was happy to acquire the electrons, right? So they are switching the partners, and then that means bromine atom gas is acquiring electron. That's a definition of electron affinity. By doing so, actually this is a high energy state to the lower energy state. So I am going to see that you are going to, your energy is coming down, and this is a EA, electron affinity, and which the direction shows. And the one that you see here is Na plus bromine gas. Okay, so far we've come a long way, right? So we have using all these four stuff, and then this is the last one. I just used that electron affinity. What's left is this one, and obviously it looks like the structureless gas, ion cloud, finding its own place in lattice, right? So that's what it is, the lattice energy. So gas has no structure, solid has all structures, and just arrange it. So their energy is coming down, and this is a delta H lattice. And then I have just complete my circle. So what I want to emphasize here is, I want to go back to my original drawing board, which is here. This is the most important component, which is I highlight in yellow. This is the where starting point. Sodium and the bromine, whatever the state they prefer to be at the room temperature and ambient pressure, they can just straight form to this salt in solid, which is heater formation, or they can make this all these detours to get there. Right? So that's the same thing, right? The delta H here and delta H there is the same. You guys can solve that way. The other way that this textbook prefer is what this salt solution manual prefer is, let's just make delta H over cycle from yellow dots to whole state cycle to yellow dot. Delta H over cycle is 0. Right? So therefore, I want to put that in. And so this is delta H, same direction, so same number, same number, same number. This is just the unknown, which is just unknown, and this is the same number. The only difference is to make up this cycle, this has to go to the other direction, right? So all you got, what am I saying here is, you guys can check that. This is what I did. This is a delta H over cycle. I'm just keep track of those numbers. Okay. Bond energy. I forgot about the bond energy. Yeah, it is. The bond energy is about, you need to break the bond, is only bring the half of the bond. So this one actually has to multiply by